Hello again, friends. And so today, what we're going to be doing is looking at applying what we looked at in our last video, which is our understanding of JSaddle and how to use it in Obelisk and Reflex in general. And so I figured the most fun way to do this is to take on this little JavaScript tutorial. They explain how to do it in terms of the actual JavaScript. We're gonna add to this a little bit. Um, so we have here, this is just a static source. So big buck bunny trailer, whatever that is, and we'll see that it has a grayscale um, effect that is being placed on the source. And this is just something we can do standard with with any sort of source. And so what source we're going to use is our recorder. And so we, are going to use or do some getting of the user media stream and then display that in an element like this, um, except yeah, except with some grayscale as well. Uh, so let's get started here. So the first thing I'm looking at, if I scroll down, is it's a different one. That we have this object here that we were building up, and then we'd say processor dot do load. And I don't really see a point in us, creating an object. We might as well just instead convert this to just pure functions. Um, and so, how do we do this? So let's start by creating the HTML here. We should also start by thinking about the actual source, which is going to be the user media stream instead. Um, so I'm going to my Obelisk project. Oh. So this is all just kind of random crap that's piled up. I am just going to comment that out for now. And we also have parser error I gotta get rid of from the last tutorial. And now this should be good, except for, I must have pure somewhere. So now we just have nothing going on in our front-end body, and we are good to start with this blank empty canvas. So what do we want to do here? So the first thing we should think about is how to, let's start by building the HTML, and just with this simple video. So I'll do it similar to this. We don't necessarily have to do it like this. We could just use the source attribute, but I'm curious on if this will work. I haven't actually done this, so this will be kind of a interesting thing. I don't believe there should be any difference here. So we're going to have a video element, and I'm going to want to use adder, ladder. So let's do ladder video, and the attributes will be ID is my video. Next attribute be controls true. Width. My word. And let's set this to 480. It is technically a number, but it is really just a string. So all of these are just creating a map of text. We have the overloaded strings extension that is allowing us to write text as if it was a normal string. And I suppose I could obviously, do show 270 if I wanted to do something more dynamic, or pass in some changing height value. And I don't think we need this, actually. I think this cross origin is to do with the fact of where we are getting the source for the video. But we won't need that because we're just getting the source from our camera. What did I do there? So I'm going to stop that, and then now we have do, and so here they have embedded source attributes that we can create. So let's say now source. And also, too, part of why I haven't done this beforehand is not because I'm lazy. That is definitely part of it, I will be honest. But I think it will be good to just see what issues come up and how to deal with them. Because I know that was one of the big learning curves that I faced when I started with Obelisk and Reflex. And although we talked a lot about, different theory, we haven't really done a whole lot of application. We've done some small bits, but we haven't built up a system where we might see some new novel errors that are more particular to the kind of stuff that we're doing with Reflex. And the reason for that is because Reflex has quite a lot of power, embedded in the classes that they use, and yeah, we'll see. So, source is going to be equal to, well, I'm just going to set this to undefined for now because I'm just going to set this to undefined for now because this source will be coming from our our recorder, and yeah, so we will, I guess, we do want to specify the type as well, but I don't actually know. I think this defaults if I recall correctly, it defaults to recording as a WebM, but let's just set it anyways, so that it is very clear. Right, better to have more code than less code that is all random variables. Like it's not very clear. The more verbosity we can have in our code, in my opinion, that's better. And I'm not sure how the canvas relates here. I don't think we actually. I don't know what is this canvas. I guess, can we inspect this? I don't want that. Oh, here we are. Video. Okay, yeah. So canvas. Oh, the canvas. Okay, so the canvas is where we are actually going to display our, changed or manipulated video stream. And so I'm going to say that we need this for now. Yeah. And I'm not sure why the second source is here. Yeah, I really don't know. I wonder if that has something to do with compatibility. So I'm just going to not do that for now. We don't know if we need that. and instead do ladder canvas, where the parameters, or sorry, the attributes are my canvas, not yours, mine. Width is 480. And the height is 270. We might want to make these a little bit bigger. We will see once we get there. And I guess we're almost there, actually. Come to think of it. I'm just going to put blank because I don't want to have anything inside of this. I don't care to. And what do we have here? We have our first isString error. Maybe it has to do with this. Can I just say this for now? From the literal source. Oh, because I am using L, not ladder. Ladder source. We also haven't given it the inner description of it, so we're just going to say blank here, because since these are self-closing elements, they therefore have no, contents to them, and so we're just going to say blank. We could have, we could of course make our own little helper function, which is L self-close, or L self-closing, which only takes a text representing the tag, and you know what, and we'll kind of make it like L, how L only literally takes just the text itself, and this will be DOM builder TM. I am going to let that error happen though, so that we can see it. And so tag is going to be L tag blank. And this is a very simple error. I thought I had, oh yeah, I guess since I have data.text imported as T, I have to refer to the T namespace. And yes, so this is a little bit of a confusing error. Ambiguous type variable T0, so basically referring to the T that we've seen, like for example in this trigger event T, the reflex timeline. That is arising from the use of L here, and it prevents the constraint DOM builder TM, or T0M from being solved. So we know, it can deduce that this should be DOM builder T, and if I eliminate this, then I see that it does figure that out, and I could ask if I entered into the REPL, what is the type of this, and it would say this is a DOM builder TM, which of course takes a text. And so I'm now just going to specify that. Now, just to be very verbose, this might be obvious, but we could, put unnecessary constraints here. We need the DOM builder TM constraint because this is now a valid type signature. It is true that M must be of the type DOM builder in order for this to work. And therefore, where we can call this function, in what monads can we call this function, and so it would have to be in a monad that has DOM builder capabilities. But we could do something stupid, like also add the constraint of post build, and that would literally do nothing except annoy us. Because L is the reason that we need DOM builder in the constraint here, and post build T, like we don't have any functions of the post build type class. So why is it here? It will still enforce that we have to have post build, but that's only because we did something stupid. So yeah. and I'm just gonna clean that up a bit. And we have L self-closing. Let's do that. Let's do L self-closing. And we only need that. Oh, well, all right. You know what? I guess we will ask for the attrs as well. And this is going to be t.text, t.text. And we'll say laddr. And these will be attrs. Tag and attrs. And we would probably want attrs in this case. I can't think of any self-closing tag which we wouldn't desperately care about the attrs. For example, video is a self-closing tag, or video. I'm thinking. No, sorry, image is a self-closing tag, and what good is an image element without some reference to the actual photo that we were trying to display. And we would display that by setting the source of that image element to being, that, the URL to that photo. So yeah, now we have LSF closing and that type checks. We had another one here. Well, I'm not going to use it for ladder canvas, even though it technically would fit. It's more of a misleading function. And I guess that's our only LSF closing that. Only LSF closing that we need. So let's take a look at this. We can go to localhost. We should see, this is a video without any actual source, and there should be in here a canvas, right? So, and I guess a canvas is just, I've never actually used a canvas before, and I think I read this wrong when I first looked at it, thinking that we just create two video elements because of the two sources, but I suppose not. So, and if we look at this must be or C1, this does C1. Oh, because we're doing object-oriented stuff. So we're going to write this without doing object-oriented stuff because there's no point. There's just literally 0 point to building up a big object. We might as well have functions that we call, more atomically. I'm not sure if that's the best word to use here, but we might as well break up our logic into its smallest possible pieces, because why would we want to do more work than we have to? And that's also greater possibility for errors than necessary. Yeah, and it's not like if we created this function, right, and we just created it in the top level namespace, there's no reason that we couldn't use do load. I guess that's the main function that we're calling here. What's a better example? There's no reason we couldn't say timer callback. We couldn't reference that anywhere. We don't have to make it an object. There's really no actual motivation besides programming paradigms to make this an object. So let's see. So the next thing we should do is, well, I guess we're, not a lot of HTML to write here. We're going to do some JavaScript. And let's see. So, So let's convert this to Reflex as best we can. So what are we actually doing here? We're going to do load. This is getting the video. We're getting the elements. This is getting the context of that element. Okay. And then we add an event listener. Right. So I guess, we could use reference, well, no, we can't really use Reflex to replace this part here. We can like we saw with the dynamic DOM tutorial. We can sort of replace this get element by ID in some cases, and maybe we can here, but uh, that doesn't seem like the path of least resistance. Um, so, hmm. So I guess the first thing we need to think about here, before we can start getting into this, is what actually starts this whole event. Um, and JavaScript is really just a byproduct of an event. A user, none of this JavaScript is going to run unless you know well, I suppose not here, but none of this JavaScript is going to run unless you know we press play, right? And so how can we do this? Um, so I guess we'll have a button, um, right? I guess, do we need controls then? Controls might just make it ugly. We might just take out controls. I'm just going to have a button that we are going to click, and it's going to say start videos. Um, Although, because we're using the media recorder API, we might not want to do that, because we actually might want it to be. Um, hmm. So we want to come to our page, and immediately it is showing us in normal form and us in grayscale, coming from the media recorder API. I meant to move my mouse towards the camera, which is just above this in real life, but not in the video. So instead, our event actually shouldn't be from a button, but instead should be um, the event that starts off our video should not be from a button, but instead from the post build event, and that will be of the entire DOM. So if I have post build here or get post build, right? I'm going to call it post build event to be very clear. And now this will be the event that starts things off. And so how do I do this? So I'm trying to remember. I know. So we need pre-render here, and the reason for that is because we are doing JavaScript, so we're gonna have to um, basically just I think of it as notifying, um, are notifying the compiler that we need to convert this section of code to um, JavaScript, or need to sort of pre-process this JavaScript and then continue on with building the DOM. Because at the end of the day, the entire thing that we're really doing here is building a DOM. And so we could use pre-render to, and I'm just going to leave this blank for now. We could use pre-render to basically create a script here. And yeah. Although I believe we would want to also have perform event, um, because this will be based on the post build event. I'm not. I know I did this last time. I don't know if we actually need that. We will kind of play around with that. Yeah. Let's see. And so if we look at the types of pre-render, I should go over that. Pre-render is expecting two monads, one which is on the server and one which is on the client. And then it represents this DOM space, and the result, or I shouldn't say DOM space. It can be, doesn't necessarily need to be DOM space, but it represents this as a dynamic carrying that A. Um, so let's try this without perform event at first, and I guess we'll say that this would be so we have to do get user media. How do we do get user media again? All right, we have to do a constraints object. Um, hmm. You know what, let me honestly do a little break here and just take a little bit to kind of refresh myself on get user media because I'm being a little inefficient right here. Hello. So yeah, I decided I basically this is the original doing it in JavaScript, and so basically what we're going to want to do is do this constraint object, which um, deals with the capabilities, you know, of you can get a lot more complicated with this. I just have it set to we want audio and video, um, but you know this is effectively the parameters that we need in order to do the get user media command. And this is a command which I will run in the top level of this script. Um, and so, you know, I do a bunch of setting of stuff, and then I eventually run this command, which starts off quite literally everything else. I have literally done everything in response to that event. Yeah. Now, I guess what we want to do is create this object. So, um, and this is, of course, an object in the JavaScript sense. And so we had a function object, right? I think it's just we can create a new empty object, right? So we have a new empty object we are going to do. And so now, now that we are in this statement here, we have the ability to do JSM. And that is a function of pre-render. We cannot do JSM in the base monad here. We have to use pre-render in order to make this work. So, yeah, and we'll come back to what would be done on the server, but we're effectively just going to do nothing on the server. And so JSM, the first thing we will do is, well, you know what? Let's, for the sake of sanity, I'm just going to make this into a new function here that will also allow us to get a better understanding of what we are actually doing. And so I'm just going to say, you know, get and set user media, or get media recorder, which is effectively what we're doing. At the end of the day, we want to get to setting the source object, so not source, but the source object to being get media stream object. And so we have a way which we can do a DOM query to get this video as well as this canvas. And that's what we will do. So now in our new function, get media recorder, which is going to be of the type, well, we're going to do actually, this is kind of specific to Obelisk, and just I guess I'll say the structure of the monad transformer embedded in Obelisk. We could say JSM, except that will make it actually kind of annoying to do. And you know, you can mess around with it. Um, it is kind of annoying to just to use JSM here. So you know, this is much like saying like if we had this is also just a lot more generalized way of saying it. Like for example, you know, print is something of the type IO, but we could also have print being of the type. We could make our own print, which is of the type monad IO M, and then now this works in any monad. But instead, you know, if we have this normal print, then we have to say lift IO print. And so we could ultimately do this and then just get, you know, do something like lift JSM because we're not actually in the JSM monad, but we are in a monad which has the constraint of monad JSM, which, you know what, let's just look at it quick. So, huh. Oh, I thought it was from Reflex. Well, no, what am I saying? Um, was it this? No. Well, we do have this JS context singleton, and I guess you know, okay. So I suppose I was wrong about that, huh? So yeah, this is what we're doing, and it is just simply easier to you know, to say monad JSM, and you'll even notice that with like, you know, any of the functions that you will do in Reflex is that you're never really specifying what the monad is. There's not really a point to that when you have, like, for example, if we look at something like, you know what, let's go to DOM Builder. So if we look at it, like, there's this, you know, a bunch of these instances, like, you know, this can be DOM Builder so long as the inner monad is DOM Builder. And like you'll see that with every single class in Reflex, right? This whole thing, this construct may be DOM builder so long as this M is really the DOM builder. And the reason for this is if we look at it, it's just doing lift. And so if you saw my tutorial on monad transformers, you would be familiar with lift, and you would know that it's just basically, you know, in a sense, deferring to the real DOM builder instance. So, let's get media recorder, and this is going to be something actually, we'll call it a media recorder, which is what we're going to get back. And I guess, what do we want to do with it? Or no, we don't want to. We don't even want to do that far. We just want to get the media stream, and set the source. So you know what? Okay, so here's what we're going to call this instead. Set video source object. And this is going to be an action which we are going to run at, um, you know, the instance, or, you know, once the application starts, and the DOM builds. So set video source object. This is going to do, does this have any, no, we'll say that it takes no arguments. We could, of course, easily expand it to take arguments. But what's the first thing we gotta do? We have to say obj. So obj is a JSM action, and that will result in constraint object. And Oh, what's this complaining about? Surprised it's not complaining about that. Oh, because this is just from lots of tutorials. Okay. Not in scope. Right, not in scope. So the media recorder is just going to be a nice little wrapper around a JS val, because JS vals are not restricted to any sort of form, and so we just want to make sure that we don't mess with it the wrong way. And do that. So we're going to want import by JSaddle, or from language.javascript.jsaddle, which, by the way, you could import stuff from GHCJS, GHCJS.dom, for example, and you would have the same types, but you want to stick to JSaddle. And the reason for that is because, especially on deployments, um, you know, when you try to compile your code, you will get a lot of annoying errors, but that you have to ultimately learn not to use both of them at the same time, because I could write a function which uses constructs from both, and they will type check upon being interpreted, but will be really annoying when it sees that these two objects, or sorry, these two types are from different libraries altogether. And the reason we want to use JSaddle over GHCJS DOM is because this can port to GHCJS, and so, but not the other way around. So this is more general, and so we prefer that. So now this is complaining because we haven't thought through the rest of this. Right. And now this is complaining because we haven't done this yet. So I'm just going to say undefined get media recorder. Another good complaint. Set video source object. And we're also going to want to add that to JSaddle. I'm just going to delete all of this. Actually, I'm not going to delete that. Whew, wow, I got to clean that up. So we create an object, and we're going to want to, I think we can just say that since this is JavaScript, there's no constraint with setting a value, or sorry, setting a field that has not been created yet. So we just have an empty object here, and we are going to say that the video attribute is, that we need this. So we're going to say that the video attribute is true. And so this is going to cause an issue because we haven't imported control.lens. And so we're just going to import just that value. I am, since it's a symbolic infix operator, we need another set of brackets. And this is now complaining because I don't have the actual lens package. And I'm just going to restart it. Oop. So, next thing we'll want to do is just simply set the video or audio to true as well. We don't necessarily need to do this, and I'm questioning if we should even do this because we also could run into like sound feedback issues, which is just not very fun. Oh, did I actually save? Oh, that would explain it. And this is what's used for when we fully compile. This is what's used currently, but it is good practice to, good practice, good habit to add it there as well for when we do a deployment. And now we have, oh, but this does not make sense because this is a constraint object. And I'm just thinking here, does this actually make sense? Because okay, so let's figure this out first. Import JSS, and then we go to line 139. It's complaining because we don't have a media recorder yet, so I'm just going to put undefined because I am extremely lazy. Right. So, you know what, maybe, well, here's what we're going to do. I'm just going to say, I guess I was a little wrong in that sense, but if, so, okay, yeah, so now, this is a little annoying. The class 2JS string is, I think, getting confused because it cannot tell that this is text. I think, I'm not, let's look at 2JS string because I've been wondering about, can we not just give it a string? Yeah, so I guess it's just confused about what we're giving it here. And the reason for that is because we have overloaded strings. And so I'm going to opt to get rid of that. No, that's going to be annoying. Let's make another module. So, we'll just call it js.hs. Module js where, and so this one will not have overloaded strings. Let's just copy all of this here. Oh, forgot to save it. And now that's saved. And this is still complaining. Oh, right, because we have to go back and we have to put back overloaded strings. We have to save it. So now we are just going to import, and I'll put the imports from us at the top here. So import JS. And I'll just say set video source object. And now that brings us to JS because we cannot properly compile JS first. So if I do now import control.lens, my word. Cool. Semi-working. We lied because there's the pure undefined. But I'm trying to think. Does this? How does this actually work again? Because would I need to return it each time, or pass the new constraint object? Trying to think. Hmm. You know what? Let me check. Well, I'll check via types. That is the proper way to do things. Um, no. So I guess we set, and this is lensing, but we don't need we are affecting the JavaScript context with some ref. So we are changing the value of the constraint object as it is held in the JavaScript context. And I'm just going to delete that because we don't actually need that. There we go. That looks nicer. Cool. So now what do we want to do? Well, we have our next move here is to ask for or get user media via the constraint object. So I guess how we would do this is I know we could get so we could do we could get the window, right? The window object by getting I think it's get current window unchecked. And is that actually a function? Let me just check. Get current window. Oh, it is. No. Global. But I think we have. Okay. How did I actually do this? You know what? I honestly don't even care. Current window unchecked. What the frig? What in the heck? Oh, okay. Well, I suppose it was literally just the get which caused me to have issues. So now we have the global window object, and I believe if we have the window, we can access the navigator object. I believe navigator would just also come up, but I feel like it's better to learn about window because window allows us to find whatever. So now current window unchecked. We can say window. JS navigator. So this is technically a function, a getter function which takes no arguments, which is why we have this JS. I think we also have JS0, but I'm not sure what the actual difference is between JS0 and JS. Name of the property defined. Handy way to call a function that expects no arguments. So I think these are really the exact same. I think we could use either, but I'm going to go with JS here. And navigator, and we want to do get the media devices, so we'll scope in more. JS, get media devices. Pardon me. And then finally, we will call JS1 because this expects this attribute, this function embedded as an attribute expects a constraint object, so one argument. And our function is get user media, and it expects the argument of the constraint object. And you may be questioning, like, why that works. Like, you know, I guess, well, we haven't really, none of these have asked for an argument, but this is kind of the first case where we actually are passing an argument. The reason this works is because this would fit something of the type to.jsval. And so what would the type of object be, I guess? And why does it fit here? So, oh, actually, object. Oh, stupid. I think it's literally right here. So this is an object, and we can see object is something of the type to.js file. So we know how to interpret that in a JS context. Current window unchecked is going to give us an issue because it is not imported. What does then? Okay. So this monad DOM is literally just monad JSM. Monad JSM is what we are, always working with, no matter really the context. They just wanted to have some sort of type synonym to refer to monad JS or monad JSM. So yeah, this gives us the window. We could do current window. Maybe there's a reason for why this could fail, so this would be a little bit better. But I'm just going to be lazy and assume, for the sake of speed, that this is good. And really, with any other video, you should be able to figure out how to work with maybe. So we get the current window unchecked, and then we have the window navigator. We came to this because we were trying to figure out where to import from. And so I guess import JS DOM. This seems weird because I feel like I got it from somewhere else last time. So now I'm going to add this to the build depends, as well as here. Also the build depends for the executable version. And just going to restart this because it's a little janked up. So, window navigator. And what does this give us? So this will give us a this is basically a promise, right? This is going to return effectively a promise. And where did we go? right? So we have this promise structure here, and so let's handle this promise. I have a function. Where is this? Do I have it in utils? Here we are. So what is going on here? Oh, we need also what a promise actually is. And so we have called the data constructor here unsafe to promise. I'm just, you know what? I'll come back to this in a second. This is annoying me. So, oh, current window unchecked. That's why that's still there. Okay. Nah, not in scope. JSM. Right. I'm going to change this to being of the type M, 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 where the M is of the context or of the constraint that it must be monad JSM. That will give us a little bit more flexibility. And then I believe I just have to do this lift JSM. Deriving make object is also undefined. So I'm just going to import that. And this should come from here. Is that what I have in there? Oh, I just had to. This is one of the powers of Haskell, is that I'm basically just redefining JS val. And so, you know, it can auto derive based on the instance of or make object for JS val for promise. Since this is really just a simple wrapper around it. And now we have complaints that we don't have JS in here. We don't have JS1. We don't have lift.io, which comes from control.monad.io.class. We need a new empty mvar. Where does that come from again? Control.concurrent would have it. And then we have fun. We have lots of fun. And I think this is to do with changing the no, this would be because we are using lift.io and or not. Okay, so I guess actually for some reason this needs to be. Why would this need to be? Let's see if this just goes away from going back to JSM. All right, so that works. So, I'm not sure exactly why that's happening, but um, basically this is handling a JavaScript promise. And so I'm just going to delete this because we no longer need that. That doesn't do anything. It's lifting JSM to JSM. So we start by creating an mvar, and why do we do that? Uh, wait a minute. I think that's actually no longer going to work. Pardon me for a second. All right, so I think I had a bit of an implicit assumption. It doesn't actually matter at all. Um, so the issue I had was that I thought that older implementations of JSFile used mvar, but it turns out they actually um, don't use mvar, nor do they even use IO-ref. They used to just have an JS value ref. But that's since been expanded to using IO-ref for concurrency. Um, so, yeah, so I was a little confused then. Why are we using an mvar here? And I suppose it really has nothing to do with JavaScript itself. So, anyways, but we are asynchronously. By the concurrency that we are doing with mvar, we are able to do some asynchronous actions here. So we start by creating this mvar, which you would have learned about in concurrency. We try to run the then statement of the promise. So why that matters is we have to have then here. I don't know if I actually even have a catch block. Come to think of it, I guess I never needed that. So, in the case that that failed, we would run our catch block, and then we would put that. Oh no! You know what? I remember now. It's because of because we're using fun. Fun's short for function. Um, there's no way to actually, return anything from this statement here. However, that doesn't mean that we can't put it in an mvar and then retrieve that mvar, right? So we're effectively setting a location in memory that we've agreed upon to look for the value in. And then with each action, we update the mvar in a particular way. So, yeah. And this would only affect the mvar and return the left case if we end up with the catch. And it's because we're just effectively setting what should happen for the then and catch of some promise, where the promise is really just a JS file. So it has no typing to it, but we do know, of course, that it is a promise. And so the reason we called this unsafe to promise is, of course, because we could use this to just turn any JS file into a supposed promise, but we don't want to ever be using this. In fact, we can write this in a way that we don't actually export the promise or the unsafe to promise at all. If we just say promise, promise like this would also export the data constructors, whereas this just exports the type. And whatever else we want to export. But we will come back to this. That is less important. And so, yeah, this is now something we can use to handle a promise. And how did I actually use this, to be honest? So I said right. So I wonder if we even need to do that, honestly. So I can check. There is the possibility that this is undefined. We are not able to get the constraints, like the constraints that we ask for are not available. For example, with our case, since we only are asking simply for video and audio, it is possible that video capabilities are not available, or the user just does not accept them. And I wonder if we're at a point where we can actually run this and see what happens. Oh, something went wrong. Not good. Oh. Say media recorder. Well, I suppose we're not at that point. This isn't even a media recorder. This is going to be nothing. So we can do this, and is that what's going on? Are we even calling this? Come to think of it. I also might even have undefined. I do. And I think I can just do this. Oh, that would have worked. Okay. So that's taking a sweet time. It heard me. And okay, so now go here. Yeah, exactly. This is what is expecting to happen. So this is why we have a promise here. Is that we're getting promised by Chrome that it will give us back the user media stream, and it will only do that if we accept allow. In the case that I say block, we will have our left or exception case. And so this shouldn't actually do anything because we haven't subscribed anywhere to the user media stream. But you might notice that the camera light on your laptop or computer is now flashing. Maybe for mine, it's flashing, and that it's recording. However, we're not sending those bytes anywhere. So. Yeah, so I guess let's do the stream undefined. What will this do? This yields our stream, and well, we don't necessarily need to do this. So we'll come back to this. That's yeah. Although I guess you might run into that. So let's check this out. Let's do stream undefined is the GHCJS pure is undefined. So why do we have to do this again? Good question. This is undefined. Will tell us, as I believe this is one of the, this would be a synchronous command, and this will be, this is really just I believe a wrapper that says that this will be exactly. It's pretty much just JSM at the end of the day. Um, and it's a wrapper saying that this is a pure function. So in GHCJS, where we are compiling directly to JavaScript and we don't have any backend runner, um, just you feel free to treat it as a pure function. So case stream undefined of true. And so yeah, I guess this is where we'd handle the case. And yeah, because now we're effectively we kind of added a step into what we were doing here just to see if it was undefined, but now we are handling the promise. And so I am going to use the unsafe to promise. I suppose I made that as a function, but I'm literally just going to be doing this unsafe to promise using the data constructor, and which is effectively what that is. It'll be our stream, and what else did we ask for here? What to do in the case that it is well, I'm sorry, we need to pass both handlers, one in the case that is successful, and the other in the case that is not successful. So yeah, I guess let's also use this pure.userMediaStream because since we are returning out of this promise where it can be either A, B, let's just have a little bit of type safety around that. And yeah, const pure navigator navigator request denied. So, and this will be a stream. Does that work? Right. Just gonna complain. GHCJS pure is not in scope. And user media stream is just something that I made up to wrap the JS val. And this is on line 37. For some reason, it's expecting... of course, because I've returned undefined here. So, I guess I will come back to this. I am just going to simplify and set the source object. So now I have, do I have reference to the video? I do not. So what I can do is I can say, well, I have the window, so I'm just going to say window access the document. And now here I am trying to set the video source object to being the stream. So window dot document dot get element by ID. This is going to take a single argument. So that is going to be, I believe we called it my video. We're going to use the canvas and try to see how that works. So I'll say my canvas. Let's see what happens with this. Let's see if we can directly set the source object. canvas. And I guess we'll use JSS to set the. I don't think this is actually going to work. Set the stream and handle promise. This is going to handle, or this is going to give us an either. So, and we need it to be we need it to be the right case. So let's say case stream of left. We will do something. Case that is right. We will do the following. That will be, let's call it right stream. I suppose this would have an error as well. We don't care about the error just yet. And so now the new value that we want to refer to is the stream prime. You know what? I guess it's just going to give us errors. So but we kind of need to check what we are doing so far. We kind of need to make that happen. Right. So I guess we also want to unpack the wrapper we have of the user media stream just to get the actual true stream, the true JS value. And let's see what happens. I guess this is not requesting my right. Okay, let's instead what we can do, we can just easily test if we're even close with this here. And this looks like something happened there. What happens if we say document dot get element by ID my video dot source object? So we see it's a stream. Odd. I don't use it elsewhere. Nothing else is open. Do we have a source for this already? Oh. Okay, what happens if we do this instead? This is really just sanity check and what in the? All right, let me figure out what's going on here. This is So turns out I actually just needed to press play here. I'm not sure why. I don't know. I don't know. And I did change these as well. I don't think that actually mattered. Let's see what happens. So I noticed that is what exactly I did there. Right, so it starts off like that. If we turn this on, it is going to cause a lot of echo. So let's say muted, or that's the wrong one. Add another attribute, muted equals or is true. Starts off muted, perfect. And we don't need to worry about any horrible echo. So I guess, yeah, so now we have this working here. I'm not sure why it's not working with Canvas. Because if we look at this, perhaps it is in this. So, what is this put image data? Put image data. What is that? Put image data. Okay. So then, what are we actually doing here? I guess this is now a good time to look at what we are doing now that we have the user media stream, and we effectively just want to, get those bytes in a roundabout way, into our canvas. So we start with processor.doLoad. We get the video, canvas, and then context. Okay. So, I guess let's break this down into a function we'll call doLoad. doLoad. Which takes no arguments, so it'll just look like that. And we're going to say doLoad is something of the monad JSM variety. And so what do we actually do in monad load? Okay, so you know what? For fun, I'm going. Well, no, I don't even care. I'm just going to continue to use plain JavaScript or plain, the way we were doing it. We could use the actual function from, GHCJS DOM of, get element by ID. Right? We can literally look this up, and I'm going to delete this now. Get element by ID. Self being, I don't know. I suppose this would be the document and then the element ID. But anyways, so we just want to get the current document unchecked. Doc. Doc. So, wait a minute. What am I saying? My video and then canvas L is going to be the result of JS1 get element by ID my canvas. Oh, what's this? Okay. So it is asking for it in JSDOM, but I'm going to prefer in JSaddle or from JSaddle if it does export. Nope. Okay. Jeez, I cannot type. There we go. So we have in scope our canvas L and our video L, and we're going to use this get context 2D, which, what is get context? Let me just look at this. Well, you know what? Yeah, get context. So what does this do? Returns a drawing context on the canvas or null if the context identifier is not supported. And so it looks like we can do, oh, okay. 2D. They do have another WebGL. So this looks much like how we got the original media stream. We were just probably building some sort of object here. Yeah. So, well, I guess we can't ask the type of that, but okay, cool. So now that we have C1 in scope, and we don't need this, so canvas L get JS 1, since it takes one argument, get context 2D. Oh, don't know. Okay. Good. So now we have the context. So we'll call this context. And what do we actually do with this? This dot timer callback is basically what we. Okay, I think it sets it up for compute frame. We are going to make this also pure. I'm noticing that this is updating the global state of the object and then getting context later as we do compute frame. But we are going to call timer callback, which is going to have the necessary arguments given to it in order to set up compute frame and itself. So now I guess we would say video. So the video L is going to have an event listener, which we can just simply do by JS. I guess this would be JS2 because this is taking two arguments. And one of them is going to be a fun. I guess we're not going to want to return anything from this, so it doesn't matter that we're going to use fun. Add event listener, play, and then fun, which takes a the function object, this, and well, yeah. Well, so because we're using the fun function, we have those arguments, so it's going to procure them for us. The function arguments being, well, sorry, this is more like an anonymous function, I should say. And so I guess this is not taking anything. So I don't even need to really ask or pattern match on that at all. And this is going to do, let me just, there we go. This is going to do this dot width. Okay, so it's going to set, I guess it's going to set this for later, so let's not do that for now. We're just going to call timer callback and timer callback. We will abstract as another function. And timer callback. We don't know exactly what arguments it needs just yet, so I'm going to set it up like this. So how we should do this is we need to check if the video is paused or ended. So we're going to want the video elem. Let's do, so video L, what's the actual type of this? Would this just be JS val, I suppose? We can check this easily by asking with scope type variables enabled, we can just say that it is a wildcard hole. And so, yeah, this video L is just simply of the type JSVal. So I'm going to do this, and this is not necessary, but no. You know what? I'm not going to do it. I thought I would, and I'm not going to. But we could, we could wrap that in its own wrapper, and make it very clear that, this is an L as opposed to some other JS val. But we are not doing all that much, so I'm just going to ignore it for now. And so this is going to take some JS val. And I do have a bit of a, this is a little crappy now because I'm passing a JS val around, and I might change that. I don't know. Video L and so we're not doing that yet. So if Huh. I mean, I could just use eval to write this. That might be the easiest way to go. How would I do this besides eval? Feel free to use eval, but I want to kind of challenge myself here. So I could check that video L. I could get that attribute by simply just doing paused. Is paused. And this is probably not even going to be more efficient than just doing eval, because now I'm forcing callbacks into Haskell. But, you know, this is more about understanding how to use JSM, or, yeah. Ended. Although I guess we won't really have this ended because it's a continuous stream. We will want to check if it's paused, and so what can we do here? So let's look at how to turn this into a Boolean in Haskell, because right now this is of the type JSVal, right? And that's complaining because of that. There we go. This is of the type JSVal, and so we would like to say case f is paused, and be able to inspect it to say true or false. And so how do we do that? We say val to bool. So I suppose we would have to do that as an action itself. So I'll say is paused prime, and this is val to bool is paused. So we would instead say is pause prime of true or false. And what happens here? Does that work? Are we good? And so we need to import it. And so that looked like it worked. And now we can say what should happen if it was paused, or if it is paused. So I guess we should not do anything then. Well, okay, so we don't, yeah, this is really just let's not do anything. Let's exit out of the function. So in the case that it is paused, we should really just do pure here. And now it's going to complain because, we are not giving pure here. And so let's do that. We'll return nothing out of this really. And yeah. But if it's not paused, we're going to continue on with our logic, which is this part here. So we're then going to enter into compute frame. So just going to turn this into a function so that we can map over quite easily. And so compute frame. Okay. For some reason, I was reading this is in the function of compute frame, but that makes no sense. So we're going to run compute frame now, and we're going to see what arguments it needs to be given. So compute frame, this.context1. Context1 is that context that we built, so we're going to want to pass this into timer callback. And I'm already seeing why we might want to do that. And you know what? And this will be really simple because all we have to do is say video, and then we have a nice data constructor. So I'm going to create a new type. Video equals video JS file. And actually, this is a great point to talk about because when we looked at, although I don't really make use of these functions like get, or what was it? Get element by ID. We have all of these functions. And as you can see, this is all just auto-generated code based on Mozilla documentation. And so this would be a good example here. All of it is really just, everything here is really just a bunch of new type wrappers around a JS file, right? If we look at this, this is going to take a second. And then, it will get there. I'm going to take a little drink of my Coke. And, so it's just a new type wrapper around JS file. And that's so that we can have all of these different classes around what is a allowable action with this JS file. So for example, is GObject is one of many classes that allows us to turn it into a non-parent element node, or non-element parent node, whatever that means. And that would have its own set of functions. For example, we have the function getUserMedia. And if we look at this, all of these, whatever, it works. Oh yeah, it literally says right there is a JS file. And same with, media stream constraints. This is probably just a JS file. Can't imagine being anything else. And drum roll, please. I was about to call it quits there. And it's a JS file, and you get the idea. And so we have these classes then that just allow us to deal with this very simple constructor. So yeah, for example, functions for this interface are in jsdom.mediastream. This actually won't. This link is broken because being through Google, like through our own Google server. And yeah, so I'm just going to do that. I'm also going to say new type context or canvas context equals canvas context JS file. And now we can make our type signatures a little bit better. Right. And so now we actually need to construct these by saying, hey, this is a video. Hey, this is a context or a canvas context. So that brings us back to timer callback. And we're going to run compute frame. And I believe how we started on this thread was that compute frame is going to need the context right. So I'm going to call this context prime. If you're not familiar with this syntax, this just means that the reference of context prime now refers to the entire value, whereas context refers to the unwrapped value. And so now I can just say context like that. Compute frame is not in scope because we have not defined it yet. And so compute frame is going to take this canvas context. It's also going to need our monad JSM constraint. And this is going to do some stuffs. So compute frame I suppose we didn't really need to unwrap it before because we're not doing anything besides passing it to here. So, we didn't have to unwrap it. We could have saved a name. And then now that we have this context, we can say context draw image, and we're going to need to use JS5. Now, for this, we actually could instead use, was it JSF? So JSF, and there is variants to this. Yeah, not really like JSF though. JSGF, yes. But where were we? Ooh, I just lost where we were. There we are. So JSF, what does it do? So yeah, this just allows us to use make args, and so why make args is nice is because it can be this. In our case, we could actually make this work because this would give us 6 args, and that's all we need. We only need actually 5. But if we had let's say 20 args, we might as well at that point just use a list. And so as long as everything in that list is a valid 2JS val arg, then we are good. And pardon me, one thing we could do as well is we could use existential quantification, which is a language extension that basically relaxes the homogeneity of a list. So right now we are constrained to having a list of the value a. With existential quantification, we could have, for example, this. This would be a valid list. I might forget. So if we do show So through existential quantification, we could say that we have this list of int. Int is one of them. We have a string, and we have, some user. And all of these, as long as they have a show instance, will work in this case. And so we could use this to say for 2JS val, and then have different 2JS vals in there. But yeah, we don't actually need that. So I'm gonna, you know what? I'll use JSF here. And I won't use existential quantification. Yeah, I won't. I thought I might actually want to. well, you know what? Yeah, I'm. Feel free to do it, but oh, so we also need the video. Okay, so let's also pass the video again. Video. And call this vid. And that's complaining because I haven't actually done anything there. Right, that is not anything of the JS value variety. So I'm going to need to pass the video L, the just two zeros. I'm not even sure what they do, but maybe we'll play around with that. This dot width. So what is this dot width? This is just really this dot video dot width. And so if we say video L JS width, we will get the width, and then video L JS height. Except, actually, I'm just realizing that that is invalid because these are not raw values. These are JSM wrapped. These are values that come from a JSM action. So we'll say width is here, and height is via this action. Put width back there. Did I use this wrong? Name args. Just doing some, I think, sanity checking here. So yeah, this is a JS val, not, okay. I thought that might be saying that that was a unit. It is because we are ending it off like that. Okay. Right. To JS val. Something here. So it must be to do with these. I could just say, I mean, I am ultimately just generating a string. Okay, that works. So I am curious though. Could I do val1? Actually, I probably can't because, well, then I would have to do it as an action. So I could do it, but I will not because I am lazy and I would rather just put the string there. Yeah. And so we're gonna create a frame variable, which is by doing this action of get image data. Okay. So frame is going to be from context. Why is it called context one? Is there any, okay, well, whatever. Context one, or context in all case, is going to be JS f draw. I lie. get image data. And yet again, lazily do that. And then width, height. Compiles, perfect. And what is this? Okay, so this is from our value here. What do we actually, okay, so we're going to use frame quite a lot. I will keep it as a named value. And this L. What is L? Let's get a better name than, this is length. I'll call it length because we don't want it to interfere with any other value or any other functions, like, you know, the length function. So I say frame. Data. The length property of data. Okay, so I guess what I will do then is I will say val to number. So val to number, and this, you know, on both sides of this bar here are JSM actions. So I should be able to go like this. And this will feed the result of this. So we'll get the length and then feed it to val to number, where val to number is expecting one more argument, which is this thing. Perfect. So what do we want to do here? Oh, right. So length divided by 4. I'll just say for now is length divided by 4. So what are we doing here? So for the range where I is less than L, do this. So we could obviously do that through recursion, obviously. And yeah. What is L? L is the length of the data. Okay, I guess I don't really understand. Well, so frame.data. Oh, wait a minute. Isn't this... Because we're just converting it to grayscale. This looks like we're doing something with the RGB values. I'm a little confused on why we have this number here, but maybe we will understand that. Okay. So I guess let's break this into another function, which we're just going to call recurse set data recurse set data. We're going to say for now it doesn't take any arguments, as we will see as we go. Okay, so now let's try to make what gray is. So gray, how would we get the value of gray? So we would need frame. Okay, so we'll make a new data type through new type called frame, and it will just be, of course, a JS value. We haven't added any classes to it, you know, nothing special. We could, though, easily by doing deriving and using the generalized new type deriving, and that would probably work for every single case that we could come across with this library. And okay, so gray is using frame, recurse set data, takes the frame, and it's giving a parser because we haven't finished this yet. So if we say frame data, oh, you know what? We actually, so, okay, so what we're doing is we are computing some index and then looking up that index of this, I suppose, array of data. And so we have the function, I believe it's just simply, right. So what's the difference between this? I think this is strict or something. Looking up a property based on, oh, okay, on a name versus index. So this is really just a another type synonym to effectively JS, or yeah, it's a synonym to JS, and then this allows us to specify a number, and so we are going to specify a number, which is the result of this logic here, where so I guess we have to. I always try to avoid using indexes, but I suppose we have to here. Or do we have to? I don't know if we do. You know what? I am just going to keep it simple for now. And since we are trying to work off of this example, yeah, just show it verbatim. So I suppose let's put an index here. So we are taking an int and a frame, and we are doing some monad JSM effects. In the case that I don't think it matters if we go back and forth, but I will say that once we reach you know what? Let me think about this because I'll pause the video so I can think about this. Well, that was a little longer than I expected. If you notice the times, it's now a day later. I have not moved from my chair. No, I'm just kidding. I did take a break, but came back to this, and yeah, I learned a lot to do with like arrays and just how to what's the best way to deal with them. So like I was saying, you know, could have just actually I will talk about that, but could have just you know, done eval but I didn't really want to do that. I would rather have purity in the code. So, what the ultimate issue was is basically this line here. And why was that so challenging? So we'll see here. And it effectively comes down to the backend runner that we are using, which is JSaddle Warp. So JSaddle Warp is a server that we are interacting with, which is running these JavaScript commands as a batch. And so, what this is set up to do right now is whenever we click play, where is it? Whenever we click play, we're going to do a timer callback, which ultimately results in this being called, which is getting the data from the frame by the function getImageData on the context from the video L. So what did I just say? We are getting the that one. Getting those bytes there, and actually they're displayed on the side here, because I haven't refreshed this in a while. Because this shouldn't be. Well, this is from. We'll see in a second. Not from JSaddle Warp, but yeah. So what happens here? And there's a couple notes I need to make about the differences between using GHCJS directly versus JSaddle Warp. So this here is generated from JSaddle Warp, from GHCJS, and that was kind of surprising to me. That was kind of interesting to learn. So print as a function, I was doing print here somewhere. So I was printing the data and just trying to debug what was going on, why it was taking so long, and it was interesting. So if I let's say I had print data here. It would take forever. I literally timed it. It was over 5 minutes, and then clearly something had gone wrong. So what I also tried was just simply replacing that data with the unit and seeing if I could just print that out. And I was able to. So I was able to print out very quickly just unit. So what I think is happening is that, this is not forcing the data or the thread run by JSaddle Warp to evaluate, and instead just, throwing out that data. And so why that was surprising to me is I had assumed that this function was one of the synchronous commands. As we saw in the last video, there is a little list of synchronous commands, which we can find right here. And so I figured, value to number, that I guess that's what I saw. And I assumed that the same was true with from JS file. And so why am I using from JS file? How did I even get there? So I started with, so I actually found the function that I was thinking about. It's not in JSaddle, but rather in Reflex DOM, I believe. Reflex DOM. Let me just. Foreign JavaScript.utils, and there's this function, JSON decode. And so I had an assumption about how this worked. I assumed that it was using JSON through data.asin. As there is a couple other utility functions in Reflex DOM core that do use data.asin, like for web requests, which we saw in that tutorial. But if I look at the source, I see that it's actually using the JSaddle functions to call JSON.parse on the client, right? So basically doing effectively JSON.parse Yeah. So, and so that didn't actually make sense because I guess what I would be saying is here. Well, yeah, okay, I guess I'm still not sure why that didn't work. Well, actually, as it turns out, I do know a little bit about that, and maybe I can reproduce that. I'm gonna want to get rid of that, and I might have to. Well, you know what? Actually, sorry, I can just do this simply. If I do, um, um, oh yes. So I'm looking to get the image data from this feed here. So, oh yeah, definitely look at the time. This is still GHCJS running here. And this actually has been working for quite some time now, but I don't think we would have seen it. I believe that might have been just because of the same issue with JSaddle warp taking forever, because literally the event is on this click play button. That is when this image should show up. And we will add to this so that it continually redisplays every single time that we have an animation frame. But now if we look at this, will this work? No. So I have to do a little bit of backtracking here. You know what? And I'm just going to pause the video so I can just quickly do this. Okay, so I recreated the frame, which is really just this variable here. And so if we do frame.data, we get this massive unsigned int8 clamped array of length 518,400. And so that was what was causing issues. And so I believe this is also just not going to parse for JSON. In fact, I'm not sure what I did differently here, because I think I just did JSON.parse. And so this will not work either. It does not know how to parse it for whatever reason that we do not care about. But I was actually just simply overcomplicating, because all we have to do here is use from JS file. But this is what was taking still quite some time. And so it is an asynchronous command, but yet is still for some reason taking quite a lot of time, and I'm not sure exactly why that is. And we can see that a list is valid as a from JS file argument, so long as the the type in the list, for example, int, is a JS, or it has an instance of from JS file itself. And same with character, same with everything else in this list here. So, yeah. And so I guess that brings us to back to here, and just comment this out. Cool. But yeah, so now let's look at what happens if we try to run this on using obrun. So this is the GHCJS version, and we recompile this, or refetch this. It has not been refetched in quite some time. And what happens is that this video starts, but we should see immediately our first image to the side. But what's happening is that this is stuck. So it's just taking forever to run that function and get us back this data. which will allow us to effectively re-implement this in a much more pure and simple way. It's a joke once we do that, but we can kind of see a bit of an error once we interrupt. We see thread weight, invalid argument, bad file descriptor, so something has gone wrong. Not a big deal, and the thing is, most cases this will not matter. We're not often working with massive amounts of image data, and if we wanted to as well, we could just slice this and easily test by having like only grabbing, let's say, the first 1,000 bytes of the or first 1,000 indices of the data array. And that would allow us to see that our logic is valid. And then when we use GHCJS directly, then we'll be fine. So yeah, so a couple notes about that. I think I neglected to mention that what we saw with the, well, I guess it won't be there. Yeah, it won't be there anymore. It will show up again, but that how the reason why the entire image array showed up in our console is that we have this. Well, I had this lift.io print data. And so in GHC, that information would show up here. And painfully so, I have done that before, where the entire array will start printing out and slowing down my computer a bit. And but yeah, but in GHCJS, it will print in console with the log. So kind of interesting there. That's also like, for example, in I believe it's in GHC or GHCJS, lift JSM is actually just quite literally lift.io. So yeah, and that's because we're dealing. That's because the IO. What the IO action that we're doing is communicating with the JavaScript context, and that's really something we haven't actually talked about because it's not really important to learn, and maybe now is a good time just because we have enough of a understanding. But this is this JS context ref, and when I first started, of course, the first thing I looked at was the Hugel documentation as opposed to the repo, which does a little bit better of an explanation. And so I thought I had to figure this out, or provide this JS context ref. And so, as you can imagine, I was a little confused because that's a pretty complicated thing. And so if we were to dig into this a little bit more, we would see that the JSM monad is this reader T of a JS context ref, and so this is what allows us to have kind of any different multiple different, almost polymorphic, interactions with some runner. Right? We don't actually have to care about what the runner is, so long as we can build a JS context ref. And we could, in theory, build our own, but there's quite a lot to it. And you'll actually see, too, if you do, I won't do it in the video, just to not scare anyone, but, well, no, not run JSM. So I think run JSM will eventually take you to seeing the run JavaScript function, which I'll pull up here. And we can see it's a little bit more complicated. And so it's going to run any of these asynchronous commands, and the synchronous commands, and provides us this way to interact with it. And so any of the runners implement this function. For example, JSaddle warp has an implementation of this function. Quite literally, every single one that we see If you dig into any of these packages, you see that they use run JavaScript. But yeah, and so now, now that we're gonna decide to use GHCJS for the rest of this tutorial. Of course, again, we could just use eval, uh, but I simply just don't want to. I would rather write this in a pure way, which we have done here, and I will explain in a second. But one last note is that it will then be important to make sure that we have added all of our modules. So if I comment this out and we try our first crack at using GHCJS, where the instructions are in one of these tabs. You know what? I'll just go. And so we can see how to how to build our application as if it were in production. And so when we eventually learn about Obelisk deploy and how that works, we will effectively be just using the same sort of Nix commands that we are running here. So we don't need to be Nix experts here. We just need to be able to follow this tutorial. I have my test app ready, but I'm going to destroy it so that we can do it again. And now, wait a minute. I need to make my directory first, test app. You can, of course, call it whatever you want, but update the instructions to use that name instead of test app, of course. And so we'll see this. I will go through this on video the first time. Feel free to skip through it to the. This is effectively going to cause an error. But what's going on here is that we are using template Haskell to turn our Haskell code, our pure Haskell code, through template Haskell into JavaScript. And so this is going to output a all.js file that we could run directly through Node. And of course, for some functions like for console.log, this is a console.log function here I built. I guess that is an easier example, accidental but easier. That will just be, of course, turned logically. I'm sure we can imagine how that's going to turn into JavaScript. But if not, it's going to effectively just become, console.log a. So yeah, and then delete that. You know what? I won't delete that just in case anyone has skipped ahead. They can now see this new thing here. And so yeah, now this is you can see what the what GHCJS is doing, outputting a ton of warnings. I have 719 warnings. Wow. And somehow it knows. This should fail. Although it did get pretty far. Now, I maybe there's a trick that will be used to avoid the error, but if you haven't added the other module to the exposed modules, it will not find. Yes, exactly. It is saying in non-layman's terms that we cannot find this set video source object. And where is that coming from? It is coming from js.hs. And what is this function? It is our main function here that we are calling in frontend.hs. Right? So, yeah. And so I think that explains it you know, because it's just trying to link and not working. So anyways, if we do this, and then now I'm going to pause the video until, you know, well, yeah, I'm going to come back to you guys once this is built. All right, we're back. So that now compiled because we have added JS. And so what are we actually doing here? So this from JS val allows me to turn that massive uint, unsigned int 8 clamped array directly into a maybe int, and the maybe comes from JS val. So this can throw an exception. It makes sense that anytime we are going from, we're trying to marshal um, JavaScript values to nicely typed, Haskell values, that there can be just an inability to parse that data or to structure that data, and effectively what is meant by marshal. Um, and so, and so now that we have that, I believe we've discussed everything up here. I have also taken out this length because what I realized is that, well, now that we have this, I actually don't need it, and it was really annoying because it forced it to be a double, which then forces me to truncate it or do something like that, which doesn't really feel like it makes sense because why is it even a double to begin with? So whatever. But anyways, we can instead do length in this way, and so how we get to that anyways is we first check in the case what the data is nothing, and so I guess I'll just say, you know what? Let's see if we can throw how to throw an error here. Oh, and I am a fool. There's one last thing I'm forgetting. This doesn't really matter. We don't have any real config, but let's just do this for the sake of it. So if we did have any config and wanted to use that, as we will see in future Obelisk tutorials, this is how we would copy our config to our new project. And the reason for that is that config is treated separately from the rest of the project because we might have private backend configs that we would not, want being passed around through Nix stores. And so anyways, now that that's compiled, this will immediately run, and we have our app at localhost 8000, and we will see the data being displayed. There we are. And that was really quick. So, interesting. I mean, we kind of know why it's slower. I mean, we're working over WebSockets with JSaddle in the other version. So, naturally, now that we have actual JavaScript, like now that we're literally working in JavaScript, but we're just producing this pure, well-typed JavaScript, this is instantaneous. And so, yeah, and I actually have filed just a little issue, just saying like, how would I do this quickly with JSaddle warp, which again might just simply be use eval. And there is actually ways that I won't get into here, but if you look into the internals of how JSaddle, Reflex DOM, and yeah, and GHCJS DOM all work. There is the use of this language extension. This is language CPP, and I believe it doesn't stand for C++, but language or C preprocessor. And so I won't go into it here. There are there is great documentation on language extensions, including that one. And so we could see how to check whether or not we are using GHCJS, and if we are, use this function, or define this function as, eval, right? We could have compute frame having different definitions, whether it's under GHCJS or under GHC, and GHC being JSaddle warp. So, oh, look at that face. And so, yeah, so, okay, so now I guess we kind of get into what the heck are we actually doing here. And that is how we must understand the rest of this. So, I was wondering, like, why exactly are we doing this logic? Or, like, it looks like, at first, at a high level glance, I thought we were just skipping to every fourth in some way, or going by the fourth, and we are effectively doing that. But we are actually just skipping the fourth index, or in the zero indexed array sense, index 3, index 7, yeah, and so on and so forth. And the reason for that is that this array represents RGBA. And what is RGBA? Oh, here it is. So the A is the alpha value, and which I'm still curious to see why we're not touching it, because all we're doing is affecting these three, and it results in some color. But that is effectively what we're doing. We are setting gray, or getting the value gray, based off of the RGB values. So this is, for the first iteration is going to be index 0, index 1, index 2. And then on the second iteration, where I equals 1, this is going to be index 4. So it will not be alpha, but the 1 directly after that. So, if we're thinking in Haskell terms, one thing we could do is group it into 4, right? I could turn this into a list of lists of ints, where each group is a group of 4. But I'm just a little lazy, so I'm just going to check that the length is divisible by 4 by checking that the remainder with rem is, the remainder of the length of RGBAs with respect to 4 is 0. And if it's not, I will have some error, which is another thing I need to look at. But we'll come back to these errors in a second. And after we explain this. And so if that's true, then we will run our grayscale function. And so grayscale is ultimately what I was working towards, why I care to get away from eval, because now we are doing our logic in Haskell. And we have better types to work with here. So what we are effectively doing here is we are just replacing the RGB values with the computed gray value, which is just the mixture of the 3. And so what that ultimately ends up being is that we unpack our RGB. We don't touch the alpha. We just put it back into place, because we're creating, now that we're back in Haskell, we're doing immutable, recursing to create a new immutable list, from one immutable list to another. And so we just need to simply place it. But we compute gray by the sum of the 3. And I'm just realizing that I forgot to divide by 3, because that is what we do. And yeah, and then we just simply replace each of those values with gray. Um, and then recurse. And so now that we have checked up front that this is in fact a list of 4 at a time, I can be 100% confident that this is going to either be of the pattern, um, 4 elements and something at the end of the list, or an empty list, in which case I will just simply place my end of the list, and that will result in, this value here, and voila. So now we have a grayscale computed, and yeah, and so we set this as new data in our Haskell land. And then what do we have to do? We have to say that we have to run this command here. And so what we do is we have our context, and we have to put the frame. So first we change the attribute of data to being our new array. And again, this might be a little funny because you're going like, how does this work with JSS? Why does new data work there? It's not like a string or a JavaScript value. And the reason for that, should really clean up these tabs, is that we just need to have something that is of the type to.js file. And does this work? It does work because it fits this definition. In that it is a list of ints. And so lists work as long as the inner also has the instance, and so we see that it does, and we are golden. And of course, we can therefore strongly typify what we are providing to the JavaScript context. And like it's just like a very clean pipe, I think of, coming from originally from the JavaScript context, and then going back to it in a very certain pure way. Yeah, and so where does that put us? So we have done that, and I guess so. This function was called here, and I remember there was a note I saw about using request animation frame instead of set time out. So maybe we'll look at that once we see what this even does. Okay. So then I guess that takes us to timer callback, and we'll say compute frame. Do we even need that? So how should we do this? So I guess we'll run it first in OB-run just to do a little quick check that it actually works, and then run it for real in GHCJS. Set time out. So set time out, just a, already had that open. Set time out. Oh, and this is, oh, okay. And this is where we recurse. Okay. Yeah, I guess let's do it in JavaScript. So if we do set time out, and I guess we could just do a I suppose we'd want to use JSG. Um, JSG, because JSG allows us to use a top level ref, and set timeout seems to be of that nature. But this needs to take an argument, so we actually don't want necessarily JSG. I think we want JSGF. I'll just go to this, and then, oh, okay, so I guess we could make it a little bit more clear in that it takes okay. Um, so I guess we could use fun to make this a little bit easier, especially since we don't want to return anything from it. Um, yeah. Let's do JSG1, and I'm going to use fun. And I think what do I actually care about here? So I actually could just directly refer to timer callback. Oh, wait a minute. Set timeout takes two arguments. The 16 here is the second argument. So I guess then that's going to be a little annoying. So I'm just going to call this F. And I am going to, or wait, timer callback is already defined. But it's not because we have to. So I guess this will be a small function, and I'll just say small function such that it won't be annoying to use. Ooh. I think this should, yeah, this actually should work. I should, I think I'm overcomplicating this, but there's no reason I shouldn't have these same arguments in context. I could, of course, just also, get them yet again, but I could literally have a do block that just refetches the video L and the context, but I don't think I actually need to do that. So I'm going to say vid and context. And that should work. And then I'm going to say 16 here. And let's go back to see if this works. And I think that's the last thing that we actually have to figure out. And so it looks like this is how we are, recursing, and that we continually change this photo or canvas. And thank goodness, because oh my gosh, that is not the face you want to see. So, yeah. And why is this taking so long? So, you know what? We might as well look at how to find, or how to throw an error in, in JSM. I feel like it'll be close to here. Um, oh, shoot. So I guess it has a throw M, but so how do they do this? About the string. Hmm. Should we even throw this? I don't even know. I mean, okay, so why would this fail? So we can't parse it. Suppose we'll say, you know what? Here's what we'll do. We'll use console.log, and we will just, instead of blowing up the application, which I guess doesn't really make sense, we will just say console log could not read array for whatever reason. Oh, I know what's happening here. This might happen just based on a symlink issue. It doesn't always happen. I'm not sure why exactly it the context of when it happens exactly. But if you do see that OB run is taking some time, and I'm now going to run it in verbose. Okay, so definitely past that. Yeah, okay, we're good. So console.log could not read array. Console.log improperly formatted array because, well, because it has to be of the length 4, otherwise it is probably not actually what we expected. And so now it's asking us to import to JS file. Hopefully you're able to deduce this yourself, but I also have added data.maybe for isJust and fromJust. Actually, do I even use that anymore? I do not. Never mind. Just ignore me on that. So GSG2. Okay. Suppose we just have to do that because it's expecting a unit at the end. Oh, well, no, that's because of this. This has to be a pure function or, yeah, well, a pure function, which always produces the same type, therefore. So, how should I handle this? So I'm looking at this error here, and I guess, do I care about, there should be a way to do, how do you do integer division again? know what? I'm just going to start here. No, that is not what I want. So from prelude. Right. So, okay, yeah. So I guess I just want div. And I believe that should go away now. Yes, okay. JSG has to be imported. 143, probably just an issue. Oh, yes. Okay, so I guess this is returning a JS val. And we just need to do pure so that it type checks. And now we should be good to try this again through GHCJS. So I'm going to cancel this. And what was the command I want to do again? I literally just closed that, didn't I? I just did. So I'm going to pause the video here. Well, you know what? I'll pause the video once I start this running. So, of course, don't even know if I really need to do that or, copy that. And yeah, and of course, gonna do this as well. And I think I don't know if the ordering of this really matters. Besides doing this at the end, these two I think are interchangeable. And I will see you in a second. All right. Oh. So we are good. What happens here? Jeez. All right, it's a little slow. Probably because we were printing this out. That doesn't help. Let's do this quickly. Well, as quick as we can, I suppose. There's no reason for us to have that there, so I'm just going to redo this. All right. So now let's try this again. Okay, that was weird. All right, so maybe we do want to do that request animation frame. So what's it saying here? So this timer callback set. And so instead of set timeout, okay, how does request animation frame work? Right. Do you have to provide it I don't believe we do, but just want to make sure we have to provide it. The 16 or something like that. Although I do wonder, I want to try, and you're welcome to avoid this because of the fact that we have to use GHCJS to make use of this method. I want to see what happens if I change this value, and maybe I can get a understanding of this. Set timeout. Okay, that does not have a. Do we set a delay? Oh, why are we doing that? Okay, so this should work. I'm going to recompile this. All right, so I redid that, and it looks like it's a little bit faster. I'm not sure why we were saying a delay or something, but let's try using request animation frame. And so now this actually should be pretty straightforward, since we took out the other argument anyways. Where do we have that? Why is my brain crapping out? Oh, set timeout. So let's see if this works. And this is also not gray, so not sure why that is. And let's just take it. Hello, hello. So, okay, quite some time has passed since I paused the video, and I saw that we were getting to almost 3 hours, and so on one of the last, trials of running this through GHCJS, I started to look into what exactly was going on with why the data was not changing. So before we were using this here, and we were saying effectively, oh, I guess it's still not working. So this is what we were doing before, and we were just trying to set this new data to being the data attribute of the image data object. This frame is basically the JavaScript type of, or JavaScript object of image data. And so, although it was allowing us to do that, it did not actually work at all. I found this out by doing a lot of console logging. I, tried to set other attributes to see if I was just in fact doing something stupid. And there is a lot of synonyms that I went through to see, if maybe, again, I was just doing something stupid. Like, for example, this operator here is effectively the same as JSS. I mentioned before. Same with object set property by name. Nothing was working, but yet my code was compiling. And of course, this is a good lesson that I yet again had to learn, in that, while we are better off than just writing everything in JavaScript, anything that we do write in JavaScript is still subject to the same chaos of any JavaScript, right? Because this is just building a JavaScript script, and there are no real laws there, and so although I was able to run, setting the data attribute and it would not generate any error, the data attribute remained completely unchanged, which I was able to figure out by console logging the new data, as well as the image data object. So, and then inspecting the data attribute. So that was frustrating, but it is what it is, and it is now fixed. And so, how did I fix it? So, and this is actually a good use of new, which I don't think we've talked about yet. Right, all of this has been, yeah, we have not even used new yet. So this is kind of a good thing. It was a frustrating way to get here for me, but it's a good thing. So, so here we're using new, and new actually has great documentation with it that makes it a little or quite simple to understand. The constructor aspect is a little confusing, but we see we have this great example here of new JSG date. and then arguments for that. And so args is something we've seen before with this make args class. That can be anything of a tuple to a triple, a tuple with 6 in there. And then constructor is a make object. I wonder if this will help us to understand it a little bit. Not entirely. Does JSG even return that? Yeah, JSG returns a JSVal, which I believe is technically of the class makeObject. So interesting that that's the case, and I guess it's just literally wrapping it as an object. Um, you know, so uh, not a ton of type safety in the aspect of new, but as long as you understand effectively what we're doing with new, in that we are using a where did new go? We are creating a new object, and so in JavaScript we need constructors, and so we would do that by saying new. What's the one I just used? uint 8 array, and that takes arguments such as an array. Oh, and I forgot the closing bracket. And so that allows us to create a new uint array, which we could set to being some x. And so now we have our uint array named x. And so now in terms of what we're actually doing, this put image data has to be of the type, or sorry, not of the type. It has to be the image data object, which I should still have open. And we see that these are the constructors that it would take. And so I gave it the data array width and height. How I did that is we have already actually gotten width and height before, and that's just the height of the video element that we are using to create this image data. And there is actually a subtle rule that is enforced when trying to build it, otherwise it will throw an error. That, yes, it must be either 4 times the width, or the one that I actually saw was the 4 times the width times the height for the length of the array. But naturally that will work out from what we've done here, right? Because the length of the array is just based on the width and height to begin with. So, and another really confusing thing I got here was this new data. So, and I'm a little confused about this. I'm a little frustrated with this still, I will admit. But when I did this, I was getting a weird recursion error. And my only guess for why that is that this was expecting something of the type make args, so which would interpret this list of ints as a list of args. So I would, and we see what that looks like there, but we'll get to that. So I got this maximum call stack size exceeded, and I just put that in for a little bit more work, or a little bit more specification, but yeah. And so the reason for that is that it was expecting it to be of make args, and so it must be calling make args in some way. Yeah, and so weird. Um, And I guess I could have done it that way if I wanted to pass a single arg. But that wouldn't even make sense. So I don't know. I just wrapped it in a list, and that means that this is the one arg. I also could have just done this as a list, but I would just prefer to be a little, I don't know, as type safe as I can be in this case, and use a triple, or a tuple with 3. And so anyways, so the process that we were doing here, we make our grayscale, nothing has changed there. And and then we turn this into a uint8 clamped array because like how put image data requires an image data object, the constructor for image data requires a uint8 clamped array, and not just a simple array. That results in us doing the exact same thing with new and JSG here, both of these being available in the top level, which we can prove by saying that. And same with uint clamped array. If you don't believe me, you can try it out. And and then lastly, we call this context put image data. And so I'll just warn you that at least for me, it is rather slow in terms of how fast it renders, like the new, the new data. We can see it printing out here. I suppose it does make sense because it's a massive, massive data set or massive array that we're working with. And it could also be because in the example, we are working with an already generated, source effectively, right? This WebM is really just more of a URL and a file descriptor or file um, ending. Yeah, not really a descriptor, but and so it might be just a little bit quicker to do that for whatever reason. And that's probably because we still are, generating the array as we go, and we might have to finish creating that array. We might have to wait for JavaScript to create the entire array, and then consume that array. Unlike Haskell, where we could, do things in a lazy manner. But I guess there's not really a way we could do that, or enforce laziness or create laziness on the front end here. At least to my current understanding. So, anyways, that is everything. In terms of this tutorial, I have uploaded this. No, I haven't. I will upload this in a second. And then share the link in the description. And yeah, and so you can compare and just check if everything kind of matches up. This is the main file that we worked with, but we also have this pre-render, or rather, like the front end.hs. And I suppose at the end of the day, we did not need to do anything with this event or perform event that I thought we might have to. And that's because this is just going to execute as soon as, we load the page. And so it's not really an event, but, it is in a way kind of an event, just not like we're not making an event. We don't need to build, or we don't need to get the post build event to make this happen, like I thought we might. So we could effectively comment that out, and we would see that we're good. And yeah, and that's all. So peace out, and thanks for joining for these last 3 hours.